Lastly, let's look at problem 10. I think this is a really good problem for you to pause the video and try to do on your own first. So if you've seen all of the previous videos from this lecture, then you should have enough information to finish this last example on your own. So I would encourage you to do that. Just pause the video and try to go through it real quick. It shouldn't take you more than a minute or two. But I'll go ahead and get started on it. So here we have some proportion of people that received a flu shot in a given year. So it says in a recent year, the percentage of patients that received a flu shot was 26%. A campaign was designed to increase the percentage of patients who obtain a flu shot, and that campaign found this estimate that there was an 85% chance, that someone who received a shot in year 1 would obtain that shot in year 2. So if you got the shot in year 1, there's an 85% chance you will also get it in year 2. And they also believed that there's a 40% chance that someone who didn't get it in year 1 would still come and get it for the first time in year 2. So that's all of the information that we get from the prompt that we'll be able to use in answering the questions. Now here we want a transition diagram. So I want to point something out here about the difference between the way that a state is phrased and the way that a transition diagram or transition matrix is phrased in terms of the word problem. So let's look at the first sentence here. In the first sentence it says, in some year, the percentage of patients who received a flu shot was 26%. That sentence is not going to help us with the transition diagram, because the transition diagram or the transition matrix is supposed to be describing the probability of transitioning from a state at one time to another state at a different time. That's not what this first sentence is doing. This first sentence is telling us state information. So it's telling us the state at time 1. It says at time 1, or in this particular year, we have that the percentage who received a flu shot was 26%. So that information will go to build our state vector. The bottom set of information, or these last two sentences, is going to tell us the transition diagram information. Because here, these last two bits of information are telling us the transition probabilities. So let's use... Maybe I'll use the letters S and N for shot or not. So did they get the shot or not? So what we see is that there's an 85% chance that someone who received the shot in year 1 would obtain the shot in year 2. So that means that there's an 85% chance of transitioning from shot in year 1 to shot in year 2. And therefore, there must be a 15% chance that if you got the shot in year 1, you would not get the shot in year 2. Similarly, what we know is that there's a 40% chance that someone who didn't receive the shot in year 1 would get it in year 2. So that means that this would be a 40% chance transitioning from no shot to having a shot. And therefore, there would be a 60% chance of going from not to not. Oh, whoops, I did the transition matrix, sorry. Let me just flip these then. It doesn't actually matter which order you do these in. You can always build one from the other. So, sorry, I'll flip these. But if you'd like to just do the diagram first, if you prefer to sort of think diagrammatically, then that's totally fine. I tend to just build the matrix right away, but it's up to you. It's just a personal preference because ultimately these are equivalent bits of information. So once you have one, you can just read off the other one. So we know that there's an 85% chance of transitioning from shot to shot, and therefore a 15% chance of transitioning from shot to not. And similarly, there's a 60% chance of transitioning from not to not, and therefore a 40% chance of transitioning from not to shot. So this is our transition diagram. So again, you can choose whatever order you like for building these in general. Okay, so lastly, it says find the percentage of patients in year 2 who received and did not receive a flu shot. So what we want is the state at time 2. We want to know the percentage who did get the shot in year 2 and the percentage who didn't. And that's what this state vector will tell us. It'll tell us the percentage who live in state S and the percentage who live in state N. That's what we're looking for. And what we're given in the prompt is the state at time 1. So in the prompt it says, the percentage of patients who received a flu shot was 26% in year 1. Now remember, I have to use a consistent ordering here. So because I chose the SN ordering for my states whenever I wrote down the transition matrix, that's also the order that I have to choose for my state vector. So this has to be getting the shot and then not getting the shot. And what we found was that there's 26% maybe I should say it like this. There is a 26% chance that a randomly selected person got the shot. But phrased another way, 26% of all patients got the shot. So this would be a 0.26, and therefore this one would be a 0.74. In other words, 74% of patients did not get the shot. And now if I want the state in year 2, all that I need to do is take the current state, or the state at time 1 rather, and multiply by our transition matrix, which is up at the top there. 0.85, a 0.15, 0.4, and 0.6. And when you compute this product, you get a 0.517, and then a 0.483. And that tells you the percentage that did get the shot. So this is the percentage that did get the shot, and then this is the percentage that did not get the shot. So if I asked you something like, what percentage of patients are anticipated to get the shot in year 2, then that percentage of patients that will get the shot would be around 51 or 52%. And that's it. That's all of our notes for this course. So this material is not going to be on this week's exam. Exam 4 only covers the linear programming set of topics, but this material will appear on the final, so it is important. And you'll get some practice with this. There's not a homework assignment that's attached to this lecture. However, there are some practice problems for Markov chains on the final review, which I'll be posting soon.